Let's find the inverse of this 3 by 3 matrix. This process usually involves quite a few steps, but writing the formula for the inverse can help guide us towards our goal. So the formula for the inverse of matrix A is 1 over the determinant of A, C, T, which is the transpose of the matrix of cofactors. So first, let's find the determinant of our 3 by 3 matrix. This is given by multiplying 3 by the matrix of its minors. So that is found by crossing out the column and the row that 3 is in and using what's left over. So that's y minus 1, 1, and 1, minus 4 times by the matrix of its minors, which is 1 minus 2 minus 1, 1, plus 5, 1, y minus 2, 1. Now let's multiply them by the determinants of the 2 by 2 matrices. So that's found by multiplying a d y times minus 1 minus b c minus 1 times 1. So you'd have here y plus 1 minus 4, 1 minus 2 plus 5, 1 plus 2y. And now if we just expand out and simplify this, we have 3y plus 3 minus 4 times minus 1 is plus 4 plus 5 plus 10y. And this is equal to 13y plus 12. That's our determinant. Now, before we find the matrix of cofactors, we need to find the matrix of minors. So let's denote that using the letter M. So in the matrix of minors, we replace each of the 9 elements of our 3 by 3 matrix by its minor. So in other words, cross out the row and column, and whatever is left is your matrix of minor. So you have y minus 1, 1, 1. Then you have 1 minus 1 minus 2, 1. And then you just keep going for each of the 9 elements. It is slightly a long process, but make sure you don't make any mistakes whilst doing this, because it is really simple to mess up a sign or a number by just not reading it carefully. It helps by covering up the row or column if needed. 3, 5, 1, minus 1, and then you have 3, 4, 1, and y. Okay, now let's find the determinants of each of these 2 by 2 minors. So same thing, AD minus BC. So we have y plus 1, then we have minus 1, then we have 1 plus 2y, then we have minus 1, then we have 13, 11, minus 4 minus 5y, minus 8, and then 3y minus 4. All right, cool. Now we can turn this into our matrix of cofactors. That is our next step. So let's denote that using C. The cofactors pattern just follows minus, 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 minus like that, and then the pluses make like a cross shape. So wherever you have a negative sign in this cofactors matrix, just swap the sign out over here in your matrix of minors. So the matrix of cofactors, you just replace the negative 1 with a 1 and a 1. This would be an 8, and this would be a negative 11. And then the rest of the elements stay the same. 3y minus 4. Cool. Now let's look back at our formula and see what do we need to do. We need to find the transpose of the matrix of cofactors. So the transpose is just given by swapping the rows with the columns. So the first row here would become the first column. So this would be y plus 1, 1, and 1 plus 2y. Second row would be the second column, 1, 13, minus 11. And same thing with the third row, 3y minus 4. Cool. Now all we have to do is put this step 4 and our step 1 into our formula to get the inverse of matrix A. So the inverse is equal to 1 over, and our determinant is 13y plus 12, 13y plus 12, and then just rewrite the matrix of cofactors one last time, and let's finish off this process. Minus 5y, 8, 3y minus 4. And this is the inverse of your 3 by 3 matrix.